Welcome to section 1.3. In this section, we will demonstrate functions and variable types. Previously, we have learned about the basic skeleton of C++ program. And we will start off from there with our include-exclude string. We got, it's reaching out to the preprocessor, the function of the in and out string. So we got using namespace std, so we don't have to type in std ::cow or std command in. And we got our integer main, which is going to return an integer type, which is return 0 at the end. And we got a system pause, which is considered bad coding, but we're going to use it for the sake of learning. I'm going to go ahead and put bad next to that. Okay, first we want to declare 3 different types of variables. We're going to go with int x, int y, int z. In this tutorial, we'll be covering different types of function. We will cover function and variable types. It will be an extremely long video, so bear with us. Alright, so let's begin with different types. Start with how to put in a function. A function is exactly what it sounds like. It's a block of code that is defined by a command that will run inside the program on command. So go ahead and type in a prototype. So first we have to type in a prototype of it. So we're going to put in prototype in a comment, and then we'll type in int my function with camel caps, and we'll put in int b. Okay, we want to make these 2 variables unique for their own, because remember, it's only a prototype. And then we want to come down here and create what the prototype is going to do. So int my function, and you got to make sure you make capitalization exactly the same. Int a, or int x, and int y, because that's what we're going to be using inside of it. And we want to go ahead and create a block, and we want to do return x plus y. So what this is going to do is the function is returning a value of x plus y. So whatever x plus 1 is going to return, it's going to be returned in place of its command. So we want to go ahead and put in command in, we're going to put in x, and then put in another command in y. And then we want to go ahead and put in command out. Oh no, we want to go ahead and put in another command. No. Oh, we want to put in z equals my function. We want to put in x and y. We don't have to declare the variable types right here because we've already done so up here. Once you've declared the variable type, then you don't need to do it again. We did it down here because we need to know what variables were going to be in the parameters. So whatever the integer x is and the integer y is up here is going to be put into here and be added together and be returned. So the integer z equals my function, where the integer x, integer y added together. And then we want to go ahead and put in command out z. Let's go ahead and make it end long. That's an end L, by the way. Okay. I think that's all we need for right now. Let's go ahead and compile it. Might get an error or two. I don't believe we did. Okay, so let's close, compile, or run, I mean. Alright, and then enter two numbers, so 8 and 5. We got 13. And then press nowhere ends. Okay, now we've learned about the different function, not different function, but how to use a function. Let's go ahead and deal with variable types. So let's go ahead and explain what variable types are. Variable types are accuracy for the variable you're placing in. Using int x is considered bad. So, bad int. Your variable types vary from computer to computer, so you may want to do that. I'll do that in a tutorial or demonstration for section 1.35, which we placed in later after I do section 1.4. I'll show you how to do the different types of or how to retrieve your different types of variables on your specific operating system. So I'm going to go ahead and just copy this table I've got out of a book. Go ahead and make a comment block if we can. And we have our different types of variable types. This is just a basic knowledge one. It's probably not accurate, but you get a general idea of it. So every time you program it, basically, if you want to use you need to use a specific one, or it's recommended that you do, you want to go ahead and run a program a program to give you back your variable types that are accurate for your operating system. Okay, so we got an unsigned short int, which is not any, but 0 to 65,555. So that'll cover 0 to integer 65535. And then we got a short int, which will cover negative 32768, 32768. So what's the difference between unsigned short int and short int? Well, unsigned short ints do only positive. They won't do negative, so it'll only do positive. Short int is a signed short int. You don't need to put signed because your compiler will predict that it's already signed if you don't declare it as signed. So if you don't want it to be a negative, then you need to put it as an unsigned. So it'll be the same value added together as if 32768 and 32767 are added together, and you will get 65535. So that's how you can declare if it's signed or not, or not signed, but how to get the sign from an unsigned. Alright, so you got an unsigned long int, which is extremely longer, which is not any, but 0 from 4,147,483,647. Remember, it's not accurate. With your computer, it may be different, especially if you're running a 64-bit operating system, which I am, and I can do a checkup on the variable types. I got this out of an old, outdated book. Probably running Windows XP 32-bit. But you got also a long int, which is negative 2,147. I'm not even going to say this, but you basically get the idea. And your integer 16-bit is smaller than your 32-bit. That's a good thing to remember. In 32-bit, it's automatically basically a long integer, but it carries one extra than the long int. And then you got your character value, which holds 256 characters. So it would hold that is, let's do red. That's 3 character slots, which is 3 letters. So if you carry red, so 256 divided by 3, whatever that is, you can put in red as many times as you want. So red, 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 whatever it is, until the character slot equals 256. It won't hold any more, and it obviously won't hold any negative because you can't have a negative character. And floats are extremely small and or extremely large. If you're wondering what E is down here on the double, that's times 10. That's scientific notation for x10. Floats are used for fractions, and doubles are mainly used for decimals. So let's go ahead and see how we use a variable type. We want to go up here for a shortcut, which I recommend you do, so you don't have to type in the integer type several times. So type define, let's do an unsigned int. Well, we actually don't need to put int, but short, because remember it's going to predict it as a short, not short, but it's going to predict it as an int, and it will predict it as a sign. You never need to type in short or int unless you're not defining an unsigned short or a signed short. And then we're going to put in u short. Let's actually make this u. And want to go in and place in this everywhere we see int to replace our integer type value. So long. But we don't need to put it there because that's the main. The main's going to return an integer value. We don't need to do that. Remember to get all of the integer types that you see inside your code, or you'll get an error. Let's see if we got them all. My mistake. Alright, so compiled without any errors. Let's go ahead and run it. And we get an unsigned long. So let's go with, let's just type in an extremely large number that you know your computer will not hold. And it's going to spit out some random number just because we did some large number. And it did. That's our maximum maximum that placeholder will hold. So that's your unsigned long. That's as max as it can get. So we have to divide that by 2, and then we can only add whatever number it is divided by 2. So let's go ahead and I compiled it and ran it. That'd be a deal. And let's just do 555, and then let's do 666, and you get that added together. Now let's do what it said, what I said earlier. Type in some extremely large number, calculate. I'm going by theory here. I haven't actually tested this before, so I'm learning with you guys, sort of. 8, 9, 1, 7, 8 divided by 2. Okay, so let's go ahead and run that. Put in 999, 345, 854. Okay, it worked. And let's put in 999, 34, 585, 3, just in case. And it worked. That by 2. And there's one less. Now let's go ahead and see what happens when we type in the actual value of it. 199,869,1708. So we get the extra value. So let's put in 1 to see what happens. So it actually works. So it spits out the numbers. So let's type it in twice to see what happens. 199,869,178. 199,869,178. So, well, I don't think that's correct. And it is correct. So you can only remember the 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 program can only remember that specific number type that's in its range, but it will return that value of whatever it is, no matter how large it is. So let's change this to multiply really quick to see what happens. Just to see what happens. Now let's go ahead and pile it. And run it. Let's go ahead and get back that max value real quick. 355 06 285 12. End it, reopen it. Okay, so just to test that other theory I just came out, so I'm not incorrect in the video. 06 285 22. 355 06 28. Yeah, we can just press the up arrow and it copies it. You see what happens. Copy that by 2. And it was incorrect. Or no, 5 by 2. Right. Multiply by 355 06 285 12. And we get 1 2 6. It's pretty close to what it would be, but it's not correct because it won't hold that. It won't hold more than that. You see. Okay, so that sums up section 1.3, and we will be moving on to section 1.35 or section 1.4. In section 1.35, I will show you how to get your exact variable type from your operating system. It varies from other people's operating systems, like your development software. For other people's operating systems, you don't keep that in mind. And in section 1.4, I have no plans for what it is. I may cover more about well, we'll just see what I cover from there. I'll do it in a couple minutes. I'll come up with what I think you should know before we start programming. Or we may just make a program or a calculator of some sort. So I'll see you in 1.35 or 1.4.